The features will need to be measured after being located in order to make a decision to determine whether pass or fail the part. And so here are the list of the tools we commonly use in the measurement methods. The first one we'll take a look at is the measure intensity tool. Here's an example here. This is a program running on machine 5. On this part, there are 3 places that can be short-shotted. So here is the low edge portion. It can be short-shot. This is a mid-tab, can be short-shotted. Here is the upper rib portion that can be short-shot. Now, let's take a look at the setting of the intensity measurement. This is the first one. It measures the intensity on this edge surface. We find the surface is quite bright here. So we put the limit controls like this. The average intensity have to be on a very higher value in order to pass. We also notice that this area on the edge is uniformly bright. So we can put a control on the standard deviation like that. That means the standard deviation can't exceed 40, can't be too large. A larger standard deviation means a larger contrast. Now, beside that edge, we'll place another measurement of the intensity. We can find that this area is darker comparing to the edge surface. And it is uniformly darker. So we will put the limit control like that. So the average intensity should be low. Should be in the darker area. And the standard deviation can also be low, can't exceed 35. Okay. If we would like, we can also control the minimum intensity and the maximum intensity. For instance, we can put the minimum intensity range at like 0 to 140, let's say. Maximum intensity we can put like at 0 to 200 range. So if it detects any pixel that is brighter than level 200, it will be failed as well. So now that's about this edge, and let's take a look at the next one. This is for this edge. Now this is a very bright, uniformly bright, so we can put the control like this. Now it also measures the area just beside that bright edge. Now this belongs to darker area, and it is almost uniformly dark. So the control is like this. We will take a look at the this one, the mid tab. So there's an intensity measurement on this surface on the mid tab. This is uniformly bright. So we put a control like this. Okay. Here the other one, similar control. Now let's take a look at the upper ribs. Okay, uniformly bright, so the control like this. here, beside that edge surface, we place a measurement beside that. So this is on the wall, and this is dark. So we put a control like that. Okay. Here is another one on the small section of the edge, uniformly bright. So the control is like that. This standard deviation number can be smaller. Actually, for instance, we can put like 20. Right now, you can see the actual standard deviation is 0. However, if we put to a very small number, like 20 or 15 or 10, if there is any difference on the surface condition, it may cause rejection as well. So that in order to make it in order to make it easier to be passed, to be free from kind of noise, for instance, the gas mark something, we may put to a higher value like 40, but we can't put it to too high, and it may pass shot. So here's another measurement just beside the edge. So this is on the wall, and we will consider that as a background intensity measurement. And this is actually classified as uniformly darker. So we place the control like that. Okay. That's all of the intensity measurement on this part, and they are used in making the decision of passing or failing the part. The next tool on the list is the caliper tool. In this example, we would like to detect any short on this tab. So if there is any short happens, the distance between the two edges will be different, will be smaller than usual. So by this principle, we can actually use the caliper tool to detect that. So let's establish inspection zone, try an inspection zone like this. So you can see the searching line of the caliper tool. There are many intersection points, and with this process, the caliper tool is actually measuring the maximum distance among all the intersection points. It can also be set to measure the minimum distance among the intersection points. Also, the direction of the search can be changed, like it can be vertical. Okay, actually, the direction of the searching line can be adjusted. We can adjust that to be parallel to the edge, and also the search range can be reduced to be closer to the top of the edge, top of the part, sorry. And then we can also adjust the gap, so the gap can be smaller, and the region can be smaller. Okay, and by the way, okay, let's take a look at here. Now we should never miss this option. This checks for the reference system. So it refers to a coordinate system, this one, which was established by progressive searching method. And here, let's take a look at the edge strength. Right now it is automatically set at 40. Let's see if it makes sense. So now we can see the maximum strength of the intersection is actually like around 140. So if we place the edge strength at half of that, it may be more reasonable. In that way, it can have less chance to be interfered. Let's take a look at the smoothing and the steepness setting. They are set at 4 and 2, which are reasonable for a good picture quality. And now let's take a look at the distance control. The current distance measurement is almost 42. So if there is any short happens, the distance will become smaller. So if we control the minimum distance to be at 40, and then if there's any small tiny short happens, it actually should be detected and rejected. We can, to be safer, we can also set a maximum distance. Let's see, put it at 50. Okay, so now we can click on OK to finish this setup. Next, the Find Edges tool. We can use this tool in our measurement method. Let's take a look at this example. Here, there are 3 areas: the low edge area, the mid tab, and the upper rib. So first of all, let's take a look at the location method. We use a pattern tool to locate the low edge portion preliminary, and then we use a caliper as the secondary location method, and then we want to locate it more accurately further, and then so we use the edge to find the intersection point on the edge, and then another edge to find an intersection point on upper here, and with these 2 points we can actually construct a line which can be used in determining the orientation of the part. And then let's see, the next tool is establish the reference system. So this reference system refers to this intersection point and the orientation of the line we just constructed. So the name of this reference system is SCS03, which we will cite later on. Now we can place the the intensity measurement on the low edge portion, and more intensity measurement in this area, this one here, and this one here. Okay, and we can conclude whether the low edge portion has been passed or failed. And then after that, we like to check the mid tabs. So the method we're going to use this time is to use and find edge tool first. So click on this tool, and then let's select the find edge. Let's select let's just place this search line here, and now we want to cite the reference, the coordinate system to SCS03, which we mentioned, created earlier. Okay, here, and let's set the other parameters. Automatically it's in auto setup. We can uncheck this and manually control that. We can look for we can set the this option to either set to all edges, or first edge only, or first and the last edge. In this case, let's set all edges, and then the polarity we would like to select all edges. We can of course have other options, but in this case we'll select both polarities here. And then the edge strength, let's take a look. It looks like the maximum there are 2 maximum peaks here, so they look like close to 180, and we can try to move this line to see the change of intersection point. And actually, even if we move to 150, both of them are existing. So we can actually move to half of that, like let's take a look. There is another peak over here. So this is reading 60. So now we can actually set between 60 and 150. So set it around like about 100, like around 90 or something. It will be good. Okay. And here we like to set to the pass inspection if we find at least 2 intersection point. Like here we need to find at least 2. Then we can click on OK. And now how to determine pass or fail. So when short happens, this area, this distance may become smaller. So let's use a geometry tool. Here, you will have an option like a different construct different kind of a geometry. In this case, we'll just use this distance feature. So we'll just stay on distance, and we'll pick up the intersection point here to calculate the distance. Here is the intersection point number 1, and this is point number 2. Let's pick up these two, and then let's set up the limit. Right now the distance is 30, and if we set the distance like 10% less, it is 27. Let's set the minimum distance at 27. Then if it can't reach this minimum distance, it will be failed. The next tool is the find a straight edge tool. In this example, this program is the one that is running at machine 32, and we're going to take a look at the picture number 1 of mode 2341. On this part, that is the area, that is the edge that we need to watch by vision system, and the shot starts from here. If we take a look at the shot picture, you will understand. So now if we want to detect the shot, so one method is that we can measure this straight edge. If this straight edge is close to be perfect straight, then we can pass. Otherwise, it should be failed. So let's see what tool we are using here. Let's see this one. Okay, so after locate the feature accurately, we have this coordinate system based on the location search method, and now we can place the edge tool, find the straight edge tool here. So it is referred to this coordinate system, this one. And now let's take a look at the parameters setup. So there are different directions that you can pick up. Okay, and we can also set up the gaps to like make the inspection more intense or more loose. Okay. So about the edge strength, in this case, we can set it higher, because you see the largest strength is about 200 there, around 200. However, to be safer, we'd like to set it as low as possible, since the background is quite clear. So we can set the edge strength to relatively lower. So we can set to 39 or 40, around that. So the reason is that you don't want to, because the reason is that if there's any shot happens around the edge may not look like, the part may not like as dark as this one. It may become lighter and closer to the background color. So you don't want to miss the shot portion. That's why we want to set this strength relatively lower. Okay, and now let's take a look at the limit, which is quite important here. So this is the one we want to look into, the deviation. So the current detected deviation is 2.7. So if we set the deviation higher than 2.7, then the current good part will be passed, no problem. Now, when shot happens, because there's the edge is no longer straight, then the deviation will become larger. So we can set like, for instance, 5 or 8, 10, like that, whatever higher than 2.7. However, sometimes there's a condition. It just like, for instance, a tiny flash or some kind of a burning condition, and then the deviation may become worse. However, the part is still not shot. So you don't want to fail like a flash condition or some kind of burning condition. In that case, you don't want to set that to be too low. So in this case, we set to 15. There's another reason we set into 15, because we have other judgment conditions, for instance, based on intensity measurement. So we're not relying on the edge strength only. Okay, so this is just one of the criteria. So we don't want to set the limit to be too tight. Okay, and on the other hand, we can also set up other limit controls. For instance, what if a shot happened but the edge is still straight? Because it can be still be a straight edge, but it will be on a different angle, not horizontal anymore, not a horizontal edge anymore when shot happens, right? It may still be straight. In this case, we can actually set the minimum and the maximum angle here, right? Right now it is 359, so we can set like a 357, and then 360. Okay. All right. But however, we probably don't want to do that here, because this angle is pretty close to 360, and then when it exceeds 360, it will become like starting from 0 again. So it's more complex. So we don't want to set in this way in this case. Okay. The detect objects tool is the next one that we're going to take a look. In this case, the tab is the interested area. So right now it's a good one, and the surface is quite flat. So all the light is reflected away from the camera lens. When shot happens, the surface is no longer flat. It becomes wavy, or even worse. So there's some light reflected into the camera lens, and the area will become brighter in the image. So by this principle, we can actually place a detect object tool here to find the white blobs. So let's take a look at the setup here. The threshold is set to 100, and we want to find the bright objects. So right now this surface is, you see the histogram here. So this surface is pretty dark. The histogram reading is looks like it's only less than 25, the intensity, right? So if we place at 100, it won't reject good parts. and it should, like when shot happens, the chances that it should go above 100. And then we can set up the minimum object size to determine whether it form a blob or not. So here we set at the 15 pixels. So the reason is that sometime on the surface there is some kind of a mold condition, can also become a white blob here. But that kind of condition won't generate a big white blob. So setting at 15 is pretty reasonable on this part. And now what we will think about the limit condition. What will you set the limit condition for the limit condition? Okay, so if there is no white blob being found, it's good. If there is one or more white blob is found, then it's bad. So let's see. So we want to set the minimum number of objects to 0. So the next tool on the list is the geometry tool. If we take a look at the program at machine 21, if we look at its flow now, here is the camera image portion, and then after the picture is taken, it goes to we'll look at the mode 1904, picture number 1, and then it will go to the location method state here. So let's try to open up an original image. So this is a 1904 picture number 1 here. Let's uncheck the cycle. Click on OK. Adjust the size. And now here's the locating method here. Okay, so quickly take a look at the locating method. Okay, so caliper, try to find a point here, and then establish a first coordinate reference system by the caliper result. And then we try to find the location along X direction and along Y direction. And then further, we find an intersection point around the circular portion. And then second intersection. And then the third intersection point. And now, we're going to use, this time, we're going to use the geometry tool. This is a geometry tool. And here we're going to use 3 or more points to establish a circle. Okay, we're going to use this tool, the circle tool. And the 3 points are the those 3 intersection points we just found. And then the result is a circle. You can find a circle here. So after that, the this circular area is accurately located, and then the result is saved to the parameters. So you know the origin X and the Y stores the X and the Y position of the circle. And then the other parameter is the radius. And then we can go to the next state. The next state is the inspection state, measurement state. So here in the measurement state, we are using a distance tool, which is also a geometry tool, right? A distance tool. The distance between this point and this point. Both points, you know, they were found by the edges find tool, right? Find the edges tool. So this tool was setting to find all edges and all kind of a plurality, and then we have 2 points found. And then we can calculate the distance between the 2 points. So set the limit like this. So here is actually the spot where shot starts. So when shot start, this distance will be filled. You can see, the current actual distance is only like slightly higher than the minimum distance. So it is very sensitive. In some cases, when the surface is not clear, like if there are some dark spots on the surface, the line intersection results may be wrong, and then in that kind of case, part may be failed as well, or the result could be wrong. When shot happens, actually the part could be passed. So we want this this area to be bright, to be white. Okay. So this is the end of the distance to the geometry to use the inspection here. The calculator tool can also be used as a measurement tool in some cases. For instance, showing here is the program running at machine 5, and we want to detect if there's any shot on this upper rib area. So we place an intensity measurement tool after the feature is located accurately. And now, if we want to set the limits here to determine pass or fail, it's actually not easy for this part. For instance, if we want to set the standard deviation control here, if we set to like 35 for this case, the problem is that the standard deviation for a good part can easily exceed 35 as well, because in this area it has both bright and dark condition. It's a gray area. So sometimes the lighting condition or the surface condition can cause the standard deviation becomes larger easily. So this is a difficulty here. So we don't want to directly set up a deviation control here, but we understand that when shot happens, we have quite bright blobs, and also we have quite dark blobs here. So the bright one will have very high reading of the intensity, and the dark one will have very low reading of the intensity. So what we would like to look at is the maximum and the minimum intensity here, but we are not going to judge the part solely by controlling the minimum intensity or maximum intensity. Instead, we're going to look at their difference, at the difference between the maximum and the minimum. For a good part, the difference is smaller. For a shot, the difference is larger. So by this principle, we can use the calculator tool. So we use the minimum and maximum intensity as the input of this calculator, and then we calculated the difference by subtraction. And then if the difference if the difference is less than 180, we'll consider that as good. And then in some conditions, because this is a tougher one, in some conditions maybe the surface condition is not as good, and a good part may be failed. So we want to have a larger tolerance in some cases. So we set at 200 for the larger tolerance as the larger tolerance. And so we have two results here. Okay, one is the step result and one is the new results here. So we can click on OK as the calculator finish. And then we will use this calculator to make a decision, which we will be talking in the next session. So far, we have gone through all the tools listed here except the logic calculator. In an inspection, typically we will have to use multiple measurement tools. And each tool has its result of true or false. And then these results can be put together with the logic calculator tool. So let's take a look at the example. Like this is an example that we measure the upper rib portion here. So there is a measurement on this edge, another measurement just beyond the edge on the wall, and then the third measurement is on the smaller segment. And then all those three measurement status need to be true. That means all those three status need to be passed to make a decision to let the part to let the feature overall status being passed. So we can use a logic calculator to put the results of those three results, right? To put those three results together and use the AND calculation for those three results. So in some cases we have other situation that either condition pass, we can pass, and then in that kind of situation we can select to use OR as the calculator. If a vision system is rejecting good parts, then we will need to follow a procedure. We'll need to follow the vision system problem solving guide. We'll follow those detailed procedure here. Assume we come to the status that we have to look into the vision program, then we will need to follow these steps listed here to go through. So let's see if vision program is running and it's rejecting good parts. And now what we will need to do is to first stop the program, stop the running program, and then we will switch to the configuration interface. And we will select the corresponding inspection state. And the next step is to use the simulate acquisition tool to open the failed file. So here is a good part failed. So we'll open this image and then click on OK. And then we will look into the tools from left to the right. We'll see which one starting failing. Okay, now let's find the edge tool starting failing. Well, it should have located a point on the edge, but it didn't find any. So let's take a look at the set. Okay, it is because the maximum edge strength is only at 180, but we set the edge strength at 200, so it can't find the edge. So let's reduce that strength. Okay, if it is 100, then that's too small because it will intersect on the shadow. So we have to increase that. Okay, 130, 140, 150, that works. Okay, actually, you have a lower peak, which is the shadow, and we have a high peak, which is on the stronger intersection here. So we need to place the strength control somewhere in the middle between these two peaks. Okay, then we click on OK, and then the problem is solved. And then we need to take away, delete this tool added, right? This is the simulate acquisition tool. We added in order to open an image file. So before saving our edited program, we have to delete that. Please never forget this step. And then we will save the program. Okay. Of course, before saving the program, you need to make a copy of the original program. In case you know that your editing is wrong, then you always have the original program that can be used. Okay, and then we can switch to the inspection interface, and now we should be able to run the program again. And now you can see, the bad part is failed and the good part is passed. So you have, a good program running. All right. That's all for the steps of the troubleshooting the program.